All right, another question here. This one is chapter 36, number 9. And let me just check that. Number 9, was that the question? Yeah, number 9. And this one says that we have a concave mirror that has a radius of 60 centimeters. So if I was drawing a picture, I guess I would make it something like this, a little dotted line, and I'll put a little C here to represent the center. That's 60 centimeters from the concave mirror, which means then F right here, the focal length, is half of that. So the focal length is the radius cut in half for a mirror. And so this is our equation for a mirror, and a mirror only. And this one then says that we are going to place an object that's, let's see, calculate the image position and the magnification of an object that is placed in front of the mirror at a distance of 90 centimeters. So A is 90 centimeters. So I will put it right here and put a little 90 under here. And so if we go 1 over P plus 1 over Q equals 1 over F, we then have 1 over 90. And then we'll look for the Q. And then the F is 1 over 30. By the way, notice that the sign convention here is important. The 30 is a positive number because the radius is a positive number. And for a mirror, it is a positive when the light then bounces off and goes on this side. And so the focal length is on where the light actually goes after reflection. And so that's a positive. And if we go to solve this then for Q, I'm grabbing my calculator here. Let's see so you guys can see it. Maybe I'll put it there. Maybe I'll put it down so you can see here. But this is the 30, and I like to just do that, 30 reciprocal. Then subtract the 90 reciprocal, enter, and then take the reciprocal of that. So that's a 45. So Q is 45. Now notice Q is a positive number. Yeah, we're asked in C to draw this, so I'm going to draw it in just a second here. But we're also asked to do the magnification, and the magnification is the minus the Q over the P. So the 45 over the 90 make negative 1/2. And so the negative tells me that the image is upside down. And the 1/2 tells me it's 1/2 as it was before. So the positive 45 would be somewhere around this mark here. And the drawing would look something like this. The two rays I like to draw, the first is the easy one, the one that goes, the one that goes parallel to this dotted line, what we call the optical axis, bounces off and goes through the focal point. The other one is the exact reverse of that. The one that goes through the focal point first would then bounce off and go parallel. And so these two rays, if somebody was standing over here, would see these two rays as if they are coming from this point. And so the light originated from here. That's why we call this the object. And then spread out. And as it spreads out, it gets redirected by the mirror. And the mirror redirected it so that the light then converged at this point and then spreads out. So the optics would appear to a camera or a human eye as if coming from this point. So this is where the arrowhead would appear to be coming from. And we could do the same thing at the middle of the arrowhead, and we would get that point, and the bottom of the arrowhead, and we get that point, and so we would get an arrowhead that would be upside down. And so this would be the answer to C, after this being the answer to A. We actually calculated it, and then C says draw the ray diagrams to obtain for each case. So if we do the second case, which is B, we would again then have 1 over P plus 1 over Q is equal to 1 over F. And putting in our values, we now have, or we still have P, we've moved it to a different location. Let's see. Magnification. The object is in place at a distance of, and so now we have it at a distance of 20. So we have 1 over 20. We still are looking for the Q. The F is still the 30. That's half the radius of curvature. That hasn't changed. And so if we go to calculate our Q, we have a 30 reciprocal minus a 20 reciprocal. Hit enter, take the reciprocal of that, and we get negative 60. So that's important in the sense that the distance is 60, but more importantly maybe is the negative sign. That tells me back up here that the image is on this side, where the light did not go. That's when the Q is negative. And I'll do the magnification, which is negative Q over P. So this would be negative of negative 60 over the 20. So that's a positive, and a positive 3. So it's 3 times bigger. And the drawing, I guess, would look something like this. Here is the concave mirror. Here is the center line, so I'll call this the optical axis. Let me put the focal length right here, so that's the 30. And so I'm going to place my my object right close to the mirror, because it's only 20 away. And I'll draw the easy one first. The easy one is the one that goes horizontal or parallel to the optical axis. It'll hit the mirror, bounce off, and go through the focal point. The other one, and kind of the harder one, and harder to draw even than this one said the second ray goes through the focal point. On this one, a ray coming from the object through the focal point never hits the mirror. So it's not quite the one you want to draw, but you do want to draw one that is going to come from the object and hit the mirror. And I'm going to draw it at the angle as if it came from the focal point. See, this one up here was, further back than the focal point. So when I drew it, I just drew it going through the focal point and then the mirror. This one, since the object is in front of the focal point, but I want that same geometry, I'm going to draw it going towards the mirror, but at an angle as if it came from the focal point, because I know then when it hits, it bounces off and goes parallel. So again, somebody standing over here, what would they see? And they would see these two beams coming from some location, and these two beams are diverging, so they never actually, like this case, converged and then spread out afterwards, diverged afterwards. So when this person looked back, they would see the light coming from here. The light really did come from here, so we call that a real image. But this one would have the appearance of the light coming from back here somewhere inside of the mirror. And that's good, because that matches our negative 60 up here, right? Remember we said it was negative, and so we know the image needs to be over on this side. And so this is where the arrowhead would appear to be coming from. And if we did the same logic with the center of the arrowhead, we would get that. And if we did the same logic with the bottom of the arrowhead, we would get this. And so what we get then is an image that is on what we call the inside or the virtual side, or the place where the light didn't actually go. That's why the negative. And it's kind of far back. It's a distance of 60, and that's what makes it kind of tall. This is 3 times taller than that one, and that's what we mean by the magnification. So notice it's upright. Notice it's 3 times bigger, and notice it's inside the mirror. That's what the negative is for. All right.